Вообще-то в личном... Да.
No, se lei magari professore vuole l'aiuto io.
No, faccio così.
Ну, еще раз добрый день всем. Позвольте от лица компании «Эргонест» представить вам, вашему вниманию, профессора, доктора медицинских наук, профессора Ди Сомма, который приехал любезно, эту возможность предоставил, конечно, Александр Геннадьевич и Марина Георгиевна, которые организовали эту встречу, для того, чтобы рассказать о инновационном на сегодняшний день продукте, о маркере ST2. Позвольте рассказать о данном продукте, который на сегодня действительно завоевывает рынки и имеет очень важную значимость для кардиосектора, кардионаправления. Профессор является одним из ведущих специалистов в области кардиологии и кардиохирургии, и поэтому является основным оппонентом для вас, для того, чтобы задать ему вопросы, которые будут интересовать вас именно по данному новому продукту. Но я думаю, все детали скажет и расскажет сам профессор Ди Сомма. Спасибо.
Thank you very much. First of all, thank you to Ergonest to give me the opportunity to say with you that I'm very, very happy to be again in Minsk after a few months. It means that the last meeting was fruitful, since still somebody asked me to come back. Today we are going to share with you a very innovative biomarkers. Innovative because these biomarkers has at the moment only few years, 2-3 years of papers in the literature, but importantly impacting in the results of the journals. You can have some, papers available, but let me tell you that in the last 2 years, 30,000 patients were worldwide tested with these biomarkers, and these biomarkers probably could in the future change our cardiology approach to the patients. And then, let me tell you, I just spoke with Director a couple of minutes ago on the big opportunity that is available today to have this kind of research starting between your centers, our centers, US centers, immediately to a research proposal to have this center participating in this network that is a big worldwide network named the GREAT. You can see also the email address, totally aimed to produce important, impacting big journal, New England Lancet data, because we think that it's time now, if you want to change our future in cardiology, but also in other disease, to have all the centers working and have the publications shared, not anymore between US or between US and Canada, but let's say 5-10 centers including US, Europe, Belarus, Russia, China, because we think that it's time now that is really a small world, and the concept of global must be really inserted in the science. So since I'm so impressed of the quality of organization I saw in last visit in Minsk, I'm really convinced, and your chief was really remarked this, that this center should be really one of the first using the opportunity of a biomarker story to impact tomorrow patients' outcomes, and why not cost balancing. Ergonist was really very good in immediately understanding the opportunity to create a kind of research network, and Belarus probably joined the group. The concept of the biomarkers is now coming differently, because coming now to the concept of laboratory tests to biomarkers. Which is the difference? Why we call now not anymore laboratory tests, but we move to biomarkers? Why? What the difference is between glycemia, that is a laboratory test, or natriuretic peptides? Because biomarkers has the concept of translational medicine. I am sure you are familiar with this kind of revolution concept, that now what you think is in the lab or in the basic research, you immediately bring to the bed of the patients. This is a concept that is going to distinguish between laboratory tests and the biomarkers. And you know that the biomarkers are coming now to totally change the face of acute cardiovascular disease or other disease like sepsis or cancer. Think about troponin. You know, I don't know if you are using or not high-sensitive troponin, but high-sensitive troponin, in our experience, totally changed our life. So this is a kind of a biomarkers. The last troponin was a laboratory test. High-sensitive troponin is a biomarkers, because put you in the possibility to do immediately a decision that is going to change the outcome of the patients. This is a general concept why I think that we must do research together, producing data, because this is a kind of a time step making a revolution of the new area of cardiology patients. I'm sure you are familiar with this terrible concept of heart failure. I don't know how does it work in this country, but trust me, for us, it's really a big problem that we see every year many patients with heart failure coming back because of relapse of acute decompensation. Is that true? You have this problem, I'm sure. And anytime the patients come back again because of relapse of the compensation of a chronic stable heart failure, his ventricular functions is further deteriorated. So anytime the patient is coming back after heart failure, his life expectancy is going to be reduced. This is now a big problem, since it is expected that between 20 and 30% of people with heart failure are readmitted in 30 days. So we must absolutely to reduce this bad outcome. Because you think, I don't know if you are familiar, but people come out of the hospital, they come back very soon. We must try to fix this. This is a very recent paper that I just came out from a famous laboratory journal in the US that demonstrate that in the aim of reduce the readmissions of patients with heart failure, a biomarker that is named ST2 seems very promising. I was in the States having some lecture 3 weeks ago, and during my times there, the Time magazine had Obama coming out and saying, we must fix this kind of a problem of money because people come back after 30 days. So he decided not to pay anymore hospital if the patient was readmitted 30 days after. You know, in a country like the States, where the money are very important, this is going to be impacting. So the cardiologists in that country say, really, we must do something. We don't want any more people coming back. So we must really understand which patients, the moment is discharged, is going to be readmitted. So when you see an hospital like Mount Sinai Hospital in Manhattan, that discharge every day 25 people with heart failure and having no reimbursement, that is around $6,000-7,000 because people come back. I think that's thing they are going to think about, that we must do something. This is the reason why readmission is a big problem. This is not only the problem of US. We got the same problem in Europe, in Italy, because people that we take care now are more elderly. So the reason of readmission, because they are more complex. So we must really understand which patients is going to be readmitted again. So we must improve our patient's outcome. Now, this is my big friend Alan Meisel, that was the guy that invented natriuretic peptide, that I'm sharing all my research with him in San Diego. He demonstrates that now the biomarkers can solve the problem of the complex patients. And I am sure you are using natriuretic peptides. Are you using as routine? My question is, do you use natriuretic peptides?
Yes.
Like we do. And natriuretic peptides is now in the guidelines. So in terms of the diagnosis, we know that if a patient is coming in with a low level of a BNP less than 100 or an NT-proBNP less than 400, heart failure is not there. Then we have this possibility where now in the recent European Society cardiology guidelines, natriuretic peptides are equivalent to echocardiographic assessment. It's not a revolution. So it means that from the guidelines, at the moment you see a patient in acute phase, that you have no echo available, you can use a simple lab test to make a diagnosis. This is not me. These guidelines. Let me ask you a question. Are you following the European Society Cardiology guidelines in this country, or you are not following? This is a question to you. Okay. Are you not surprised with this?
No.
It's very important. That means that now you are using a simple lab test is going to reduce the impact of echocardiographic assessment. Of course, all these patients are going to have echocardiographic assessment, but what is important that clinically you can have some decision in a short time. And now you know there are other biomarkers. I know if you are familiar with the paper that we published a couple of years ago, Jack, myself and Alan Meisel, that are, are you familiar with the new biomarkers, mid-regional pro-MP? It seems a little bit better. If you go to this paper on Jack, we publish, this paper is one of the papers I would like to do with you in the next. This was a multicentric trial involving 1,600 patients worldwide, and we were able to demonstrate that these new biomarkers, mid-regional pro-MP, should have less caveats compared to BNP, such as kidney chronic dysfunction, such as obesity, such as atrial fibrillation. That is important caveats. Let me just describe you a simple story. I'm sure you are familiar also with procalcitonin, right? And the patient coming in with the shortness of breath, and you don't know if the patient has pneumonia or heart failure or both. With this paper, we just published recently in European Journal of Heart Failure, we were able to demonstrate that if the patient's coming in, did somebody already know this paper? It's available in the PubMed. So if a patient's coming in with elevated levels of BNP, normal procalcitonin, this patient has heart failure, not pneumonia. Most interestingly here, you can have a patient with elevated BNP, elevated procalcitonin. This patient has heart failure, and pneumonia. So indication for antibiotics is there, because really you cannot use the same drugs for any kind of patient. So what does it mean? It means that now, using biomarkers, and a lot of people will be very happy about this, you can change from the beginning your approach. So you are not going to wait anymore for 3-4 days in the hospital and decide which kind of treatment. You must start there, because you want to reduce the length of stay, improve the patient's outcome, and biomarkers are going to give you immediately indication how to start appropriate treatment. There are some problems for the biomarkers. For instance, for natriuretic peptide, you know that renal dysfunctions are going some caveats. So let me ask you, in cardiac biomarkers, which is now ideal? We move from the concept of sensitive and specific, from disease severity, prognostic related, and just to make clinical decision. We now move to more impacting the decision, because now we won't decide between two patients presenting to your evaluation, both with heart failure, of the same age, with the same cardiovascular risk, which patients can have different prognosis. And the biomarkers is what you want now. Most importantly, we start to think about use treatment monitoring biomarker. So we are in the area now of a big revolution of biomarkers. It's going to change our daily practice. I published this paper a couple of years ago, where I was able to demonstrate that if you are following brain natriuretic peptides from the moment of admission to discharge, you can have a kind of mirroring effect on what was the efficacy of your treatment. And in another paper, we were able to demonstrate that if you have, that's really revolutionary for me, a reduction of BNP of 25% in 24 hours. I repeat, 24 hours. With a value of BNP less than 300, you will never see any more this patient in 1 year. On the other hand, if you want to discharge a patient after the admission of heart failure, you want to reach a level of less than 300 and hopefully a reduction of 50%. So we have really now some indication that the biomarkers are of utility in diagnosis, utility in risk stratification, utility monitoring the treatment efficacy. But with the natriuretic peptides, unfortunately, this is the problem. Many studies are conflicting on this effect. Some studies are positive in green, and they say that if you monitoring biomarkers such as NT-proBNP, you can have a good outcome. Others are negative. So it seems that unless natriuretic peptides are of great utility for monitoring the treatment, they don't seem really on the basis of mega trial. So, I mean, the data are conflicting. So probably we need something more than natriuretic peptides in monitoring treatment. If you have any questions, or if you want to stop me, please feel free to do it, right? But if you have a question, please make in your mind and don't forget at the end. Now let's start in a few minutes, I promise you, to speak about ST2. this is exactly what we are looking for. We got a meeting 2 weeks ago in San Diego. You know, in San Diego every year we have these big biomarkers meeting between myself, Alan Jeffy, Jim Januzzi, Andrew De Maria, Eugene Brownwell, just to see what we need. And now what we need? We need to go to personalized treatment because patients are different. So we have guidelines that makes the patients all equal, but the patients are different. What is ST2? You will have the literature, and Herbalist will be very happy to provide to you all the literature if you need, so you can have them to bring you the literature, any papers you will read. But basically, this is a kind of way where we want to really understand how the patient is severe, how can I change this severity on the basis of treatment. So the concept is ST2 is a marker of severity, and I would like to impact ST2 changing the prognosis of our patients. Very simple. What is ST2? A biomarker is going to tell you how much the patient is severe and how can I really impact the treatment to change his outcome. This is something we were able to demonstrate some years ago when I was working on the fascinating idea to rebuilding the heart. At that time I was working in New York with the stem cells to try to repair the heart. And in this paper we were able to demonstrate that in the progression from the normal heart to the end-stage dilated cardiomyopathy, the main process of the enlargement of the heart was due to reductions of myocyte and hypertrophy of the remaining ones. At that time, between Piero Anversa and myself, we were thinking that the myocyte cell death was the main, this is apoptotic cell death. Remember, it was the papers of around 10 years ago actually, more probably, we were able to demonstrate that the enlargement of the heart was due to myocyte cell death. And Piero Anversa was telling me that the cell or myocyte can regenerate. I don't trust this, because myocyte cannot regenerate, because this is what's happening when you lose cell. Myocytes are replaced by fibroblasts and by fibrosis. So, although we are working still on the stem cells, repairing the heart, still the problem is this progression from the normal heart to heart failure is due to fibrotic process. So fibrosis is bad for the heart, and if you want to impact the progression from normal heart to dilatation, we must reduce fibrosis. That was 13 years ago. I was really interested to find something that was giving the equivalent of histopathological finding, but was no biomarkers at that time. Today, we have this biomarker. ST2. ST2 is a biomarker of producing fibrosis to activation of fibroblasts mediated by interleukin-1 receptor family stimulated by IL-33. The funny story that ST2 and interleukin-13-3 has a cardioprotective effect of the heart. But the better story is that when you make a knockout mice for ST2, the heart is producing more fibrosis. So elevation of ST2 is related to the process of progression of fibrosis. ST2 has a protective effect through interleukin 13 as receptor, but if you have block of this receptor has to increase, and the phenotype of the myocyte cells is going to be replaced by fibrosis. So this is a target to impact in order to stop the progression of fibrosis of the heart. What is very important, do you remember that when we spoke about natriuretic peptides, we spoke about obesity and the renal dysfunction as caveats for decision making. These biomarkers has no, caveats. So obesity, renal dysfunction, age are not confounding ST2. So when you have ST2, you are not going to think about how much is the kidney. That's important, because when you have the lab that is going to give you the results of a MT-proB on 1,000, the next question in your clinic is, what about the renal function, right? Now you have not more this kind of problem. What is the cutoff is 35. So, all message, the cutoff that is good for the heart is below 35. If you have a value greater, means that the heart is producing more fibrosis.